So when you're reading through this problem, you notice that they give you a value of Kb. And this is a huge clue that this is going to be a problem that involves a weak base. Let's go ahead and write out our important equations here are methylamine and water. Remember back to your generic equations for the addition of weak bases to water. It's going to follow that exact setup to produce hydroxide ion and the conjugate acid. As always, the autoionization of water is occurring as well. And when you're ready, we can go ahead and assign variables. CH3 and H2 is X, OH minus is H. The conjugate acid can be Y. H3O plus is P, and OH minus again is H. Let's go ahead and set up for our inputs, equations, and outputs. The first thing that we know is that the concentration of our base initially is 0.150 molar. We also know that Y initial is 0. Again, we're not going to write down anything for HI or PI. The problem tells us that Kb is equal to 4.4 times 10 to the minus 4, and as always we know that Kw is equal to 1.0 times 10 to the minus 14th. For our outputs, we're going to want to know what X is, Y, and P and H. For our equations, equation 1 will be this setup for Kb. That'll come from our first equation up there. So that's H times Y divided by X. Equation 2, per usual, is the setup for Kw. P times H. There are definitely charge species here, so our third equation is going to be a charge balance equation. Let's go up here and find all of our positively charged species. So here's one, there's one. So on the left, we're going to have Y plus P is equal to the sum of the negatively charged species, which is just H. Equation number 4 is going to need to be a mole balance equation, and it looks like our options are either carbon or nitrogen. Remember that we can't do hydrogen or oxygen mole balances for acid-base equilibria because it gets too complicated with water. So let's go ahead and we see that the book uses nitrogen. Let's go ahead and use nitrogen. So equation 4 will be Xi plus Yi is equal to X plus Y. You're now ready to plug all of this into Mathematica, and when you do, it will eventually spit out a number for the concentration of H+, which you can then use to find the pH. And that's the end of that one.